guys, Miss Venable here. In the next part of the lab, we are going to investigate solubility of gases in solution. So we're going to ask ourselves the question, how much carbon dioxide gas is in soda? And to investigate that, we are going to fill up a syringe with 100 milliliters of soda, and then we're going to invert this syringe into water baths of different temperatures. And I've actually got 3 syringes set up so we can run all 3 of our trials at the same time. So stay tuned for some data. So here we have our 3 water baths. The first one here, I put some ice in it, and you can see the condensation, and the ice has now melted. The temperature of this water bath is 8.8 degrees Celsius, so that's the cool water bath, the cold one. This one I've left out for a bit, and it should be at room temperature. So that is going to be 21.3 degrees Celsius. And this one, I heated the water on my hot plate. And let's get in Celsius there. This one is 57.5 degrees Celsius. 57.3, 57.2. So these are pretty sensitive little thermometers. Let's call that, ooh, it's jumping around. Let's call that 57.6. Let's call that 57.6. So our next step is to load up the syringes with soda. And of course it'll just drain out the bottom, so I gotta put my finger over the tip of it. And you can hear, when I open this soda, you can really hear, right, the sound of that carbon dioxide coming out of solution and being depressurized, and it sort of releases. Gases are really sensitive to temperature and pressure, so temperature and pressure really affect their solubility very much and their ability to dissolve. So unlike solids especially, they're sensitive to pressure. Okay, so here is my syringe. I'm gonna load it up with 100 milliliters, and I'll probably go over a little bit, and then I'll have to squirt a little bit out just to get it at exactly 100. I don't want any air trapped in here. You know, you guys that are in the medical, going in the medical fields, you will learn how to load a syringe, but I guess this will be your first lesson with soda pop. So I went over 100, and I'm going to put my plunger in. Okay, I don't want that air trapped at the top, so what I can do is flip this over without spilling, take my finger off, and that will release the air. And I probably have more than 100 milliliters in here. Let's see, I got like 120. So then I'm just gonna go over to my sink, and I'm gonna squirt a little bit out, holding it upright. There we go. Okay, now I have 100 milliliters of soda, and I'm ready to put it in my beaker. So to put it in my beaker, I'm gonna hold the tip, turn it back upside down, and I'm gonna drop it into my water bath. Okay, and then I'm gonna repeat that process for the room temperature syringe and for the warm syringe. And I've actually already set those up. So let me show you what those look like. And you can see that I'm already starting to get big bubbles. So those big bubbles tell you that the carbon dioxide is coming out of solution. And you can also already see that it's starting to collect in the top. This empty gap here between the plunger and the level of the soda, right here, empty gap right here, that's where the carbon dioxide gas is collecting. Okay, same thing is happening in my room temperature beaker, but a lot more carbon dioxide in that one. And then this is my warm one, and a lot more in that one. Okay, that one has the most. And that's what we would expect. So we're gonna let this work for a little while, and I will check back in with you in about 10 minutes. So it's been about 10 minutes, and I can see that all of my syringes have a bunch of carbon dioxide in the top. So let's actually take some measurements. This is going to be the volume of carbon dioxide released. So record this in your data tables. All right, let's take out our first syringe. And to get a proper reading for the carbon dioxide, we're just going to flip it upside down. So remember, this was all the way to the tippy top. But now I can see that the level of soda has gone down because the top of this has filled up with the carbon dioxide gas that got released. So let's record the volume that I released. That's going to be 15 milliliters for the cold water. For the room temperature water, that's going to be 40 milliliters for the room temperature water. And then for the warm water, that's going to be 75 milliliters of carbon dioxide gas in the top. So in this lab, we want to investigate the amount of carbon dioxide that stayed dissolved. So I did a little research to find out how much carbon dioxide Pepsi has in it. And I found out that in 100 milliliters of soda, which was the sample in our syringe, it should contain about 0.62 grams of carbon dioxide. And at standard pressure, that would occupy a volume of 314 milliliters. So what we just measured was how much carbon dioxide came out of the solution. And what we need to think about is how much carbon dioxide remained in the solution. So your next step is going to be just to do a little calculation and figure out the volume of carbon dioxide still in solution. So you're going to subtract the data that you took from 314 milliliters and show the work for that. And then you're going to create a little graph of milliliters of dissolved carbon dioxide versus temperature. And you'll have 3 data points, one for each of your syringes. All right, answer your analysis questions and then take a look at the solubility curves for your conclusion questions. Thanks for joining me for your lab data. This is Miss Venable. Bye.